everybody see me? Kind of, sort of. Hi. Welcome back. We're going to keep wiring today. I'm going to grab some more wire from the garage. I also turned off subscribers only mode. If you want to leave a comment without subscribing, that's available now. I didn't realize that was even on. Pebbles is here too, although she's on the floor without her camera. There she is. Just a quick look at. Here, let's go. Right there. Alright, where was I? I was doing the power wiring. And you can see right here, I actually grabbed some DIN rail grounds. They actually, so not only is it a pass-through, but when you clamp these down, they clamp down metallically on the DIN rail itself to ground it. And I'm not talking negative ground like DC stuff. This is the AC line voltage earthing or grounding, as you call it, just to make it safer. Also, I attached the webcam here to a posable lamp, which actually seems to work well. So, we'll keep running some wire. And I realized that I could always just run basically solid 14 gauge. I actually had a scrap chunk of NMB laying around, so I stripped that out in black and white. It's a lot easier to work with on these non-moving parts. I wouldn't recommend it for any of the moving parts, of course, because you bend this a few times and it just breaks. So, do power to, so basically the 48 volt power supply, and then to between the 24 volt and, well, basically the DC wires from distribution to here, and here, to here, to here. Oh, and between the power switch, the power inlet, and the power supplies. Nice part about solid wire also is you can basically form it and bend it into place and it'll stay. Have a heat advisory for our area today. You know, it's only in the 90s Fahrenheit, which is actually kind of unusual for the Pacific Northwest, because the humidity is also somewhat high-ish, I suppose. And as the joke always is, you know, oh, it's a dry heat if you're in Arizona or the southwest of the U.S. It does get quite hot there, but the humidity is a lot lower, so it's more tolerable. But up here, Of course, when you're doing wiring, you want to make sure the wire you're using is rated for the amperage and voltage. This is a 500 watt power supply, so on the 24 volt side, so 500 watts over 24 volts, maximum of 20 amps output. So really I should be using 12 gauge wiring for the output, the DC in. And really the only thing that is going to draw that much is the heated bed, so just between here and the MOSFET we'll want to use 12 gauge wire. You can use 10, be better. I actually have some from the, I believe this is actually from this printer when I stripped it apart in its stock form. Here's the positives over here. Okay. Yeah. There's the bottom, right? 3 inch. It's nice because these ones already have the connectors on them. Unfortunately, I don't really want to just cut it for the sake of, I'll have the wire go like this. Don't really want to cut it for the sake of, having it all neat and whatnot. So that'll be negative over here. Might actually have to double up the negatives on that. Be in there, which means bed voltage out. Over there. It looks like they actually, the negative is a lot longer, so the bed positive over here. Certain arms in the way. And I still, I don't know, I think I have to do some sort of cable chain perhaps, because I don't think these wires are going to be, I don't know, it's not long enough at all. What is this going to look anyways? Well, there's a snag. Let me reevaluate this and come back to it later. So I want the wire, the heated bed wire to, I don't know if you can see this, I want it to attach, crooked, I know, sorry. I want it to attach here to the side with some of these little zip tie guides, printed and twist them in. Well, supposed to twist in. This is probably for when goes on the ends of the 2040s, not the fingers. This will also give us a little pathway for the A and B motors, CAN bus umbilical, all that, to cleanly go up from down here in the corner to up to the top. I might have one go up on that side too. Let's make it evenly spaced at least. Yeah, so it'll be something like this once all done, but you have to make sure, of course, you have enough free travel to have the bed go all the way down, all the way up. It'll probably end up being probably right about there, realistically. just a little bit through this little corner here. I almost wonder if there's even enough room in there. Yep, nothing left. No sheep. Conundrum. Maybe we'll have to rebuild that connector later. Make a longer wire to go there. Might have to take out this corner guide. I don't know if that'll cause the printer to fall apart. It looks like that's how the frame is held together. Well, at least I can get the switch wired in now while we get these covers up. I will need a couple spade connectors, printer, and wire. Let's get this back. There we go. Alright, so if you can see, I'm prefer the insulated ones for the hot. In the neutral you can get away with using the bare. Better if you used insulated for everything, really. Fortunately, the printer's got all of its covers on here, so we don't have to worry too much about fingers or anything getting in there. So neutral is that one. I made it difficult because I put all this together before putting the connectors on. It might be easier if you do this with the switch out of its spot. Which means I guess I can try to yank it out of there. One more of these. Oh yeah. Switch the power to common distribution. And neutral. So we have mains power hooked up. should be able to just plug it in and turn it on, and we can double check all the power supply voltages to make sure they are correct. And working. Recommended before you hook anything up, of course, to the boards. You don't want to fry your Pi or your octopus board, whatever you're running. So, a good view for you. Can you see that all right? Okay. Oh, I need a power cord. Alright. Plug. Well, if the stream suddenly ends, it means it tripped the breaker. So, plugging in. Ooh, we got fans. We got fans. And the breaker's still going, so. Alright, we're going to just measure the DC voltage. 24 volts for A. Here we've got 5 volts. 5.14, I guess. And this should be 48 volts. 48.2. Okay, so those test all right. I actually replaced the fan. That's the factory Ender5 power supply, and the original fan was just junk. With grease-filled plastic bushing. I got some better fans for it. Where did I put that? No, I can't remember. I put the old ones on there. These are the ones I ordered from Amazon, the Winson, I'm not sure what to call it. You'd have to reverse the polarity on the connector though. You have to depin it because it's actually backwards from the stock Creality power supply, even though it's the exact same connector. Check the polarities, guys, if you ever have a fan replacement or anything DC related. So next, room power. I don't even know why I did the all those Wago connectors. Guess they were a little redundant. Extras. So those should tuck down there. Okay. I can just zip tie right to the EMS board. So we got on the screen here, it says for the Octopus Pro, because we're going to do 48 volts for A and B, and then the rest are just going to be 24 volts. On their GitHub it says the up to 60 volt high voltage stepper drivers, you can select with voltage with a jumper. But I make sure I put it on the correct one. Does it go to motor power or power? I believe it's motor power. Motor power port maximum voltage is 60. Main power port maximum voltage is 28 volts. So, okay, 48 volt will go to this one, 24 volt to this one. Okay. So, what do we have here? Bunch of DC wires. Pre-terminated with connectors. And 14 gauge. Oh wait, I already took care of my high gauge wire. I can use 14 for the rest. So we'll do positive, negative, negatives on this side. So I'm going to give it the 24 volt first. Woo! Printer says it's 78 degrees in here. Well, for those of you who are metric, 25.8 C ambient air temperature. It's getting a little warm. Might have to go turn the AC on. It's pre-crimped or pre-tinned. I want clips in here. I think that's probably all we're going to need to go between here and here. Oh, shoot. I think is bed power separate, even though it's just going to be the nothing about bed power. I believe we need to do a small jumper between here and here just for the bed power, but it doesn't have to be much current because it's just going to turn on and off the MOSFETs. Oh, Pebbles, are you squeaking? Are you squeaking? I gotta do something about that. Any idea? These right. Yeah. Oh, come on, man. Got these little printed zip tie things. Oh, of course, it's printed at such an angle now. Let me sit at an angle. Of course, I got elephant strip problems on the print. And no deburring tool. I don't know what it is. Oh yes, the AC turned on. Whew. Zip tie right to the grid. negative, so negatives on this side. Under, and there's right two, there's where we'll cut it. Save those for jumpers. I really should use a blue one, but I'm running low. I'm finding anyways. I'm just going to write this underneath. Probably shorten those up. Don't need to. Polarity. Check. Polarity. Positive. Set. Oh man, look at that. I even hooked that up backwards. That would have been really bad. Always check your polarity before you do a power up. That would have fried it. Definitely double check everything. Double, triple, quadruple check, whatever it takes. Positive on this side. There's kind of an art to zip tying also. Clean that wire even later without tying down to something. Okay. Sometimes the problem is you just never have enough zip ties. Now for bed power jumper. Which only needs to be a short little run. And everyone's probably still at work and school and whatnot right now. Suppose you'll probably watch this when it's not live. Feel free to leave comments, ask questions. I will answer them in the comments when I get them. Wiring is a daunting task for some people. I'm an electrician, so for me it's what I do anyways. I'll be happy to help if you don't understand how something works. Is it a little jumper or a big jumper? The little jumper would take up a lot less stuff. Yeah, I'll make a little one. I'll make a little one. So like I said, since we're not powering the giant heated bed off of the opticals board, it doesn't need to have the huge gauge wires go through it because it's just powering a MOSFET. Which is pretty much, if you're wondering, like a solid state relay but meant for DC voltages. The reason you can't use a solid state relay in most cases, like I actually have one right here for a potential future build. Where's the camera? There it is. Got this on sale, 15 bucks at a electronics discount store. This one's rated 240 volt, 25 amp on the heat bed control side and 3 to 32 volts on the DC control side. I was thinking I could just use it for this, but I realized it is a SCR or sub-controlled rectifier, which if you've ever used one in little hobby electronics pieces, basically once you turn them on and the power starts flowing, you can drop the input voltage to off, but the output would remain on until its power is interrupted. Which would not be good, because then your bed would just be full blast the entire time. Probably have a meltdown. I did confirm that on the manufacturer's website. It cannot be used for DC bed control. Of course, once we get to the stepper motors, that's where it gets a little tricky, because I noticed when I built my Chiron wire, I think it was the Anycubic, or the motors that Anycubic supplied, because I reused the factory motors there. They, the 4 wires going to the steppers had to be crisscrossed for one of the coils. I can't remember which one. Whereas the Creality motors that I recycled from something else were not. They used a straight pin connector. So if you ever have problems with your stepper motors, not like they're buzzing or they're not moving, you may want to check that. Which just involves depinning one of the connectors and swapping 2 of the wires with one another. Yep. Negative. Positive. Big arms in the way again, isn't it? Down. You guys still see what I'm doing? Did I bump the camera? Ah, jeez. Sorry. There we go. Okay. In case you're wondering, I got the webcam on a lamp, so I can move it around. Give it a try for a while, see if it works. Oh, I'm not gonna put that. Okay, yeah. 24 volt, not 48 volt. That will fry some things. Disaster approved. Negative. Okay, all of those connectors are complete. So, all we now have for heavy power connections is going to be the bed itself. Basically, power, the positive goes here, and we'll just do negative off the power supply, because there's another screw available over here. 48 volts. Only one connection from here to here, so that's good. Ooh, does that have... I don't know if my 48 volt power supply came with any little... That one over there. I don't know if it came with a shield for this side. I'll have to see if there's a printable file here. Oh, either way, it's still PC side, it's relatively safe. Of course, we need to make sure we set the jumpers so I don't forget, because I want the A and B, which I have no idea which one's the A and B are they're supposed to be. Jump. Okay. Wire to motor power, wire to main power. So which one do I want to use for? Alright, hang on. I gotta look this up. Oh, high tail. Alright, well, let's see. Let me see if I can reposition this camera now so that we can see the ouch. Oh, the weight of the lamp is too much. Maybe you can come over here with this little wide angle. How about that? A little better? Kind of sort of. Oh, jeez. Blocked by the. Whatever. So, I guess we gotta decide which one we're using for A and B, which I guess is the first two. I don't seem to have a designation already. Yeah, because it says all 8 of them can be used for really any of the steppers. So it's this jumper that's, you can see it right there. Hang on, what if I bring up a, let me bring up this over here. So what we're looking at is this one in the corner. You can see my mouse. Oh, come on. Too heavy for the spring. So we're going to set the jumper here. Tiny little pliers. It says if the jumper is inserted on the left, the driver voltage is motor power. It is main power if it's inserted on the right. I'm assuming so. I'll be flipped around, of course. If I'm standing here to my right. Wait, what? Oh, duh. Okay, so their default position, default is main, which would be 24 volt power, but we have 48 volt going to motor power, which is these jumpers selected to the left, or towards the power connection themselves. There, and oh, come on, jeez. So these two are A and B now. Let's see, so I need, shoot, I only need 4 stepper drivers on this thing, 2 for Z and 2 for A and B. The extruder will be driven right from the EBD36 board. Here, got the drivers. Ta-da. But I wonder if I need to do anything before I install them, like other jumpers and whatnot. So A and B will be these guys, and the remainder will be these ones. Back here for a minute. We've got all this pretty much done. So the Raspberry Pi, to get its power, we need to sacrifice a USB connector, or the other dangerous way would actually be to use one of the GPIO pin 5 volt supply to power the board from, although I can't remember where I heard that they say it's better to power it from the USB-C port because there's a built-in voltage protection, so that would be nicer. But basically, from here to the Pi, that's it. And then USB-A to C between here and here, which they even include with the Octopus board. Although it's probably pretty long. I have a short one here somewhere. Yeah. Let's try to slide that over so I have just enough room for a connector. Little excess USB. Might have to flip that around, I'm not sure. Actually, yeah, if we do it that way instead. And with more room for all the connectors, if I put everything kind of routed around this way. During setup, I actually didn't like using SSH on the last one. It was actually easier to directly connect a monitor and a keyboard and mouse to the Pi to get everything set up with the CAN bus. It's you know, removes one layer of complexity there. Well, I'm gonna go take care of some other stuff today, so I think that's gonna be the end of the stream. I know that pretty much. Oh, someone's joining me finally. I was just about to give up. Well, not give up. Complete for the day. I need to figure out if I can take this piece out here. I don't know if you can see that. Can you see that? The little corner frame? Because it looks like these were meant for the wires to route up in the corners, but with that frame there, I can't actually fit anything. So I'm going to remove these two corners, but then I may have to do some sort of reinforcement in the corner to make up for its being missing. Oh, pebble, are you squeaking down there? Are you squeaking? Pebbles. Plus, I need to do a resolder or reconnect. The bed wire is not going to be long enough, so I may just. I don't even know if I want to keep this connector, but I really don't want to solder to the board either. So I could just build a new one of these, or de-pin it, resolder a longer version. Because I need it to go through the corner and then to the power supply and to the MOSFET. And this one's not quite long enough. So that's all for today. Thanks for watching. Leave comments, like, subscribe, you know the routine. Let me know if you have any questions about what's going on in here, if you're trying to build your own. Doesn't necessarily have to be a Mercury One either, because I mean really this is the same procedure in a Boron or VZ-bots, etc., etc., or even a custom whatever. Alright, see you on the next one.